probably the last video on the functions. Yeah. Well, we will be having one more video, but that will be like coding and practicing all the concepts that we learned about the functions, not new theoretical concepts. Yeah. So let me ask you a question to actually make you understand about this slide. Let me go to the Jupyter and ask you about a few questions. Let's say you have you have this particular function, and you, let's say my add universal. Let's say we have written that function maybe two or three videos before. Let's say you have this function. You have written this function and you are very, very excited. Wow, what kind of masterpiece you have generated. It can add an arbitrary number of values passed in it. Wow. But this particular function is written inside this particular file, which is mastering Python 0 to hero. Later on, let's say 2 or 3 months later, you were writing some code for some project, or you were doing something somewhere and you were writing code, and there you just needed a code for adding a lot of values together. And then you just remember, oh, I have written some function somewhere. How can I use that function? One way is to just go back to that file, mastering Python 0 to hero, and just copy this function, this code, and paste in the new file, run that, register that, and then call that happy. What if you want to use, let's say, 100 different functions? Let's say you have written a lot of functions in a lot of different files, and now you want to use all of them. And let's say this is a repetitive kind of demand. Several times you notice that this usually happens, that this particular kind of function you require almost in every project. Let's say a set of maybe 50 or 60 functions that are required always. One way to do that, as I told you, is to just copy paste those functions in every file, run them, and do that. Another way is to make a module, a file containing just those functions, and whenever any of those functions is required, just import that module into your coding file, which is one line of code, and then access all the functions as if they were actually available in the code file that you are working on. So that's about making modules of. So module is basically a Python file that contains functions that you want to use in several different coding projects, or the functions that you don't want to write in the functions having the implementation that you don't want to write in your current coding file. So you can have several of those functions stayed somewhere else in a different directory. They're residing there. Whenever you want to use any of them, you just import the whole module and use the functions. So module is just a Python file that can contain a code for you that whenever you want to use, you can use it. Normally it contains functions, maybe more than one function and several functions. Normally it contains functions that you repetitively use, and that you have written once in very careful way, and then now you want to use it again and again in several different ways. You need not to write the function definition in every coding file you need. You just make one coding file, or that is the most important for you. That is called a module. Wherever you want to use any of those functions that are there in that module, you can call it, you can use it. So that's about the modules. We are going to I'm going to show you one example of making module and how to use that. But to use the module, we need to actually specify the path where the module actually resides using this sys module. So, and then we have to do this import kind of commands, and then there is some work that we need to do to actually get this module running in our code. So in the next video, I'm going to tell you what that extra work, very little amount of work, what that extra work you have to do. So here, for example, my funcs.py, that's my Python file, and it contains these two functions. And let's say I want to use one of these or both of these functions in some other file, and that file contains this particular code. So in the next video, I will show you how to actually make and use the modules. Yeah, so hope to see you in the next video. Okay, in the last video I told you about modules. Module is just a Python file that can contain a code that can be used anywhere if you want. Normally the modules, they contain a lot of functions, but they can contain variables and other values and so on. Think about file myfuncs.py that contain these two functions, and think about a different file, maybe Jupyter, maybe you're working in a Jupyter notebook and now you want to use these two functions. So you first have to import another module called the system module sys. You have to make this path available. There are a lot of built-in modules that are already there in the path, already there in the search path. When you want to call a function, it is written in some module that is already in the search path. If you are making your modules, you have to either copy those modules into the modules that are built in, or if you want to maintain them separately somewhere else, then you have to add the path of these in the search path as well. And the way to actually insert this path is sys.path.append, and then you actually write the path of the directory where this module file, one or more files, are located. Once this is added to the path, now you can write the import, and you can import your file and your file as it is, or you can import your file with some other name if you want. You can rename that on the fly if you want. Once this is imported, now you can use all the functions like the built-in functions. The implementation of these functions are not there in your coding file. You are just using those, and you can now import these module into some other file and use there and so on. For very large kind of projects, it is good to make modules. Actually, it is better to make packages, which is actually the directory structures that contain modules. But modules at least are really good to for maintaining a large amount of codes, or actually the functions that you want to use again and again. So let's let's make a module. Why not? So let's make a module. Let's go to Jupyter Notebook. Let's create another file. Let's say new Python 3, and let's name this file as let's name this file as my universal. Let's use underscores. My universal functions. Let's say that's the file name. Let's create another notebook. Right now it's just a notebook. Let's define some functions. Let's say we want to define one function as check all args. Let's say that's the function. It receives, let's say it receives a dictionary like input, and then it checks the type. Let's say check type of all args, and let's say you write a function check if not numeric. Let's say you want to write a function that just accepts a lot of arguments, and you want to check whether any one of them, if any one of them is not numeric, you want to return, let's say, a flag. Otherwise you want to return a true, let's say. So for example, you may need this function in several places. Let's say in your code you're expecting numerical inputs, and if the input is, and let's say there are a lot of variables that you are working on, if any one of them is not numeric, you might want to check all the variables and their values. So one way of doing that is just to create a list, and that's it. I mean, that's and you may have several of those. I mean, you can check all of them. Maybe here we do not need the dictionary kind of argument, so maybe we just are happy with just one. So let's say so the output, let's say output is, let's say, or the return value, ret value, let's say that is already true, and we will say, okay, for x in args, let's say for x in args, if x is instance x is int float, if that is true, then we are happy. But if that is not true, then there is a trouble. Then we say, okay, if this is not true for any value, then we just return false. Okay, we just return false. I mean, we need not to break anything. We just return false. Return means return, whatever. Otherwise, if we finish this loop, if the loop finishes successfully, and there is no return statement that is called already, then we return maybe true. So we do not need actually this variable, let's say. So this function will return true if all the variables are either int or float. If any of them is not of this type, this function returns false. Wow. We can have another function maybe. We can write several functions in the same cell or in different cells, either way. Define, let's say, another function, universal, or add all values. Let's say add all, let's say numerics, add all numerics. And it also contains, let's say, args, and the goal of this function is just to add all the values and return the sum. So let's say s equals 0 for x in args, s plus equals to x, and that's it. Then return s. Let's say these are two functions, and maybe one more, the name of this, or some variable. Let's say I mean, these are two functions. Now we are out of the function, we are writing something else. Let's say my name, let's say that's a variable. My name, this my name variable does not belong to any of these functions, and my name is Python course, let's say. That's my name. So that's it. That's a file with the name my universal functions. So what we do is we download this file as a .py file. So what we do really is we go to file. Let me just zoom this out so that you can see the download options. We go to file menu. We download this as py file. So Python file. So let's download this. Or we can write this Python file as in some other editor if we want. So open folder, there is a Python file here, copy it. Now copy that file, and now you're free to go to any, for example, any folder if you want. Just for example, you go to somewhere in your directory and make a new directory. Maybe you want to make another directory. For example, go and make a directory maybe in D, let's say, or maybe in E, let's say, or maybe in C, somewhere. I mean, make a module anywhere. For example, in C, make a new folder, call that folder as my, or any name, whatever name you want. For example, my module, or let's say utils, for example, utilities, or whatever name. I mean, let's call it as ABC, for example, ABC, whatever. and you just make that and just copy that Python file here, my universal functions.py. Now if you go back to your where is the Jupyter? Here is the Jupyter. Now you go back to your code. This is your file. Go back to your code. Let's say this file is no longer here, and what you do is you import sys, that's a system module, then sys.path.append. Write the path here where the module is located. So the module right now is located at ABC. This is the path of the module. Once done, you can import what was the name of the module? You need to know that. That was my what? So I just don't remember the name. Let's import my universal functions. How it appears, actually when I have added this path, then this import command, and after the tab completion, just fetches that file. So that name might be very lengthy, so you can rename that as, let's say, my fs or whatever name you want. So you import that. Once you have imported that, now you can use the functions if you want. For example, you can check the implementation of my fs dot. If you see dot add numerics, you want to check the implementation of that here. Remember, this file is no longer in this particular file. This is located somewhere else, and you can call this function like the built-in functions, my fs dot add all numerics, and you can have, for example, let's say accepts the input arguments, let's say 2, 3, 4, well, let's say 6, and that's it. That's the return value. You can save the return value in some other variable, let's say C, and then later on you can print this C or do some stuff with this C. That's one thing. Another way of importing the same thing is, let's say you don't want to use all the functions, you just need this add all numerics. Let's say that's the only function that you want to use again and again. So you need not the other functions. Let's say for this particular file you do not need the other functions. Then what you can do is you can just say, okay, from my universal functions import add all numerics, and you can rename this function as something, and you can call that function the same way. So you do that. Now you need not to write any dot kind of thing. You just call add all numerics because it is imported now, and you say, okay, 2, 3, 4, 5, 6, 7, and you save that in, let's say, D, and then you print D if you want, or do whatever with that. That's it. Or you can import multiple functions, or you can import all of them. Other than modules, there are, for complex codes, this is not one module that is there. There are several modules, and the several modules may be arranged in a directory structure where the directory and the subdirectory and the subdirectory and so on. So the modules that are arranged in directory structure, although they are accessed much like the same way, that directory structure is sometimes called package, and these are basically the packages that are most useful. And we will be seeing some data science packages like NumPy is a data science package. Then we will be seeing pandas, that's a data science package. We will be seeing matplotlib, that's a data science package for plotting and visualizations and stuff. So package is just the modules that are arranged in directory structures. So now you know what module is, and we actually missed to import the name. To see the name, we have saved a name there as well. So let's go back and do that and see how many things are available. let's go to some other cell, an empty cell. So my f's dot tab completion, my name is available. Remember that was a variable? Yeah, that's available. So the name is Python course. So this module file does not require to only contain functions. It can contain any information, any data that you want to use in other files, other coding and stuff and so on. So yeah, that's about modules. In the next video, we will practice about these functions a little bit. We will be seeing how to call a function inside another function, how to make a lot of functions that are calling each other and so on. So we will be practicing more about these functions, not theoretically, just on Jupyter Notebook, just to get a better look and feel of functions more. And after that practice, we will be then jumping towards data structures starting from strings. So hope to see you in the next video. Okay, before moving on, let's just practice let's get a good grip on functions and multiple functions and handling those. And the best way to do that is to solve actually a problem. Remember, we solved a problem when we were done with if conditions. Then we solved another problem when we were done with loops, just to get a good grip on loops. Let's solve a problem. Let's just solve a problem using the functions, just to get a good idea of functions. What kind of problems should we solve here? Should we solve an older problem? Last time we solved a problem using loops that were sorting a list. Why don't we solve the same problem but in a different way? So let's go to Jupyter and see our file, Jupyter file. We have actually solved a function somewhere using loops. Just let me just find that out. Oh yeah, they're here. So given a list of numbers, let's this, make another list, or maybe the same list, that contains all the items in the sorted order from minimum to maximum. Your result will be another list like this, and we solve that using loops. Okay, let's solve the same problem, exactly the same problems. Let's solve the same problem using a different way, using functions, just to get a grip on functions. So let's say that's our problem we want to solve. So that's the problem again, and we want to solve that. So how can we solve that? To solve that, let's first define a function. Let's just make a function. Let's just make a function that let's say define find minimum, and the function accepts a list and returns the minimum value in the list, not only the minimum value of the list but also the position of that minimum value. So find minimum as well as minimum as well as the position of the minimum in the list. So how can we solve that problem? That's one standalone function. No matter what list you pass in, it will find the minimum. Okay, as long as the minimum is defined for the items of the list. For example, the list items are, let's say, all numerics. Okay, how can we do that? Let's say minimum value is the list 0. That's, let's say, the minimum value, and right now the index at the minimum value is, let's say, is 0. Okay, like we did in the loops. Like it is kind of the same code, but let's write a function for it. Okay, so that's a function, find min. So how can we proceed? What should we write here? Let's see a counter. Let's say counter is, let's say, or I maybe. Let's say the counter right now is 0 for x in L if x is smaller than our minimum value. If that's true, then the minimum value indeed is x, and the index where we found that is I. Okay, great. Else do nothing. I mean, else just go away. And I plus equals 1. So move on. So I is just the position. So I is moving on and on and on as you follow the list. and m contains the minimum value, and idx variable contains the position of the minimum value. So that's the function. For readability, we might be adding an else clause just to write boss, and that means the if condition finishes. I mean, if this condition holds true, do that stuff, otherwise do nothing. That's just because of readability. If you want, even if you don't write the else clause in pass statement, even then everything is fine. So let's call this function just to test whether this function is working properly or not. So let's just find, oh, we haven't returned anything. We need the minimum value as well as the index. So return minimum value as well as the position. So return that. Okay. Oh, but we are returning that inside the loop. That becomes in the body of the loop. Oh, no. That's bad, because even in the first iteration the return will be called, and even in the first iteration the function will finish. Indentation, remember indentation? Now that's better. Now this is no longer inside the body of the loop. Great, that was a bug, we fixed it. Great. Okay, so let's call it find. Let's receive a, b. So a will contain the minimum value and b will contain the index of the minimum value. So find min, for example, and the list, let's give it the list 1 3 4 2 3 4 0 9, let's say. Now the minimum value is 0, and that minimum value appears at 0 1 2 3. That's the third index. So b should be 3, a should be 0. So let's see what's the value, what's the result. So print ab. So a is 0, yes, and the position of minimum is 3. I guess it is working fine. Great. So that's one function, find minimum. Let's find another. Let's write another function, swap. So define another function. Let's say swap values, and what we do is it actually accepts two indices, index 1. It actually accepts a list, then two indices, index 1 and index 2. And what it does is it actually swaps the value of index. So index 1 value should go to index 2 position, and index 2 value should go to index 1 position in the same list, and then it returns the list. Okay, great. So so that's a good example. It accepts a list type variable. It accepts index type variable, which are integers. Great. So let's define a variable temp that contains L idx index 1. Just store it in a temporary variable. Then at this particular index 1, just copy this value. Don't worry, we will see lists in detail later on. Now now at index 1, the value of index 2 is copied, but it is not overwritten because we already have saved the value somewhere before that copying appears. So L at idx2 is simply temp, and now return the list. So that's how you can swap the two values if you want. Great. So let's just check it whether the two values are swapped or not. So let's say list is 2 3 6 and 7. Let's say that's the list, and let's say we want L2, that is swap values, and let's say we pass the list, and we want the values to be swapped at position 1 and position 3, which at position 1 the value is 3 because the position starts from 0, and at the third position the value is 7. So we want these to swap. So the result will be 2 7 6 and 3. Let's see what's the result. So let's print L2, and yeah, it works. Great. What else do we need? So we have find minimum function, we have swap values function. What else? So yeah, what should we do? Now let's write the main function, sorting. let's write that function, and we will use these kind of functions inside that function. We will call these functions. So let's define sort list. Let's say that's our function. It accepts a list and it returns a sorted list. Okay, what should we do? What do you think? What should we do for the very first time? Well, first of all, we should check whether all these list it contains the list contains all the numeric values or not. Let's say we are just doing this for numeric values. So we should first check that all the arguments are of numeric type or not. For that, we should write a function that should do that. Oh, remember that function is all written in a module. Remember that module? We made that module ourselves. So we can import that module if we want. Import remember that my universal functions, and we just need that function. We just need that function. One of just from my universal functions import what? Import check if numerics, check if not numeric as, so you can write that function name something else, but just this. So you import that function. Now you may be able to use that function. So after that, you can use that function. If check if not numeric list. Remember that function returns true if all the values are numeric, otherwise it returns false. So if it is true, then move on. If it is not true, what should you do if it is not true? If it is not true, then you might be printing an error. List does not contain numeric values, maybe that, and then you just return. That's it. I mean, return. Don't need to write anything in return. Fine, great. So else, we need not to write else because this return will take care of that, but it is for readability, it is good to write else. If all are numeric, then what should we do? Okay, what should we do if all are numeric? What we do is we will be doing what? We will be finding minimum. We'll be finding out the minimum, and then we will be swapping the minimum from what should we do? What we have already a function find minimum that we can call just right away. We have a function swap values that we can call right away. We already have used this function. How can we combine all these functions? How can we use all these functions just to achieve the problem sorting? We want to sort a list. How can we do that? Okay, yeah, that's it looks like yeah, it looks like a different thing. Maybe so let's just write out. Let's just for x in the list. Let's start thinking here for every element that is in list. For x in list, what should we do? We should find out the minimum and swap the minimum with x. So we should find out the minimum as well as the index of the minimum, and should swap it with the value x, and everything will become great. Yeah, I guess yes. Okay, so what we are going to do is we are going to maintain a counter. Right now the counter is 0, which is just the index. What we are going to do is we are going to find out the minimum and the index where the minimum lies. So by find minimum in the list, so it will return us the minimum as well as the index where the minimum lies. And then what we do is we will say okay, Okay, what we want to do is L is actually L is swap values with index C, swap values in the list with index C. So index C should be swapped with IDX, yeah, and C plus equals 1. Will that work? Will that work? So after this, will the whole list be sorted? So let's return list L. Is that true? I mean, we are finding out the minimum value one by one. The only catch is the list is updated here, and oh, there is a problem. When we are finding out the minimum, we are finding out the minimum from the list, and every time the same minimum will be returned. That's a big problem. So looks like this find minimum function is not doing our job. What we need to do really is we should go to find minimum function and give it that start your find minimum from a particular index. So don't search the whole list to find the minimum. Start finding out the minimum from the following index, for example. So let's give a start index and maybe an end index, but let's give a start index. So start searching the minimum from right from there. How can we change all the code right now? Oh, that's a bad thing. Let's change the code. Let's say that's the start index. Start index. Let's say this. The index right now is start index, and I is also start. We may use a range function here. That might be much more feasible to us. So let's use a range function rather than this. Let's change the coding whole lot. That's a bad thing. We need to change the code for I in range, starting from start index, starting from start index, ending at length of the list, and doing a step of 1. Okay, now x is really list at the index I. Okay, if x is smaller than m, then this is that, and index is I. Otherwise this, we need not to do this because this is happening automatically, and rest of the story is same. I guess yes, that will work out. Okay, great. Oh, there is a problem. Oh, we just missed this colon here. Great, we fix it. Okay, now swap value is there. Maybe this works, maybe it doesn't, maybe there is a bug. Let's see. Let's just call this function. So let's call this function L2 is sort list, and let's pass the list as 2 1 5 3 minus 8 17. Let's pass this list and see what it returns. If it returns fine, we might be happy. Otherwise we will see where is the bug, if there is a bug. Oh, list does not contain numeric values. Why not? List does not contain numeric values? Why is that happening? List actually contains all the numeric values. Where is the problem? Check if not numeric. Let's see the implementation of check if not numeric. Let's see that. Check if not numeric. Let's see the implementation. And where is the bug? Because all these are numeric. So check if not numeric, x in args. If not is instance, then return false. So if everything is int or float, so if x is int or float, then otherwise return true. So it returns true if all are if all are numerics. So it returns true if all are numerics. So not true means false, and it why it is returning false. So let us just see why it is returning false. That's a bad news. That's something is happening wrong. Let us just see how this is working. So let us just check if not numeric, and let's pass the list, this list, and let's see what is returned. Let's just print the return thing. Print. It is either true or false. So it returns a false. Why it is returning a false? It is a bad thing. Why it is returning a false? Let's go to the file. Let's go to the file. Here. Sorry. Let's go to the file here in this directory. Let's open up this. Maybe we open this in simply a notepad. Maybe a notepad, why not? Or maybe some other fancy editor. Let's open this up and see what is happening. Edit, format, font. Let's have a bigger font and see what is happening. Let's have font of 20. Yeah, bugs are bad. They're really bad. For X in args, okay, if not is instance, so first of all, is instance this, it will return true always, okay. If not true, which means false, then we'll move on and the loop will be running. If anywhere where it is finding out basically. So this is working really fine. Let's write this function somewhere inside our notebook and see what is, let's say, rather than this, let's write this function like check numeric 2, check if not numeric 2, and let's call that function and see what happens. Check numeric 2. It is returning false again. Why it is returning false? That's amazing. Where is the false? So 2 is integer, yes. 1 is integer, yes. So true, 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 true. All these are true. Oh, -8 might be a problem. -8 might be a problem. Let's see. Maybe, I don't know. Well, it is still false. I mean, I'm stuck here. Guys, I'm stuck here. I don't know what to do. I have to debug this function. I have to go inside that function and see what is happening. So what we really, args, oh my god, the big trouble. Yeah, I found the error. We are passing a list, and that list is just one argument. That is not a lot of arguments. We have to pass all these arguments in a different way. I mean, if you want to, you're getting the bug. The bug is we are passing one variable, not a lot of them. 2, 1, 5, 3, 8, 17. These are not all different variables. For example, if we just go inside and print x, for just first x, it is all the list. It is not the variables one by one. Let's see. Yeah, I found the bug. Great. Yeah, see, it is not a lot of variables. It is not a lot of arguments. It is just one argument that is in the form of list variable. That's the trouble. What should we do? Should we go inside and add another function, check if not numeric for lists rather than variable number of arguments? What should we do? Let's write another function that check for the list. Let's write here check numeric 2. It contains a list, for example. Just accepts list L. or maybe L or whatever, X, or it's just simply you can call the or L list, and it goes through all the list and does the same job as previous. So now this will work. So the function that was there in our module is no longer working, and it will not work. Yeah. So we are not going to use the function that is in the module. We are going to write another function that will help us here, and we have written that, and here we go. We just chain that function with that, and we just register that again, and let's see what happens now. Oh, there is another error. Which error? Find min missing one. Oh, we did not find this. Find min is missing the starting index. So the starting index is C. Great. Great. That's a problem. That's a huge problem. List is sorted. Oh my God, list finally is sorted. Oh, huge, huge, huge. So you see, you can call the functions inside other functions. You can call the functions from modules. If they are no longer working or no longer beneficial for you, you can write new functions. You can call them. You can, yeah, all that stuff. I guess that lengthy video taught you a lot of lessons, how to code actually. And this actually happens when you are doing tasks that are really big. You have to define different functions. You need to define different functions for modular approach and focus on each function as a separate entity, and that makes much simplicity in managing the code and bug fixing and all that stuff. You see, I fixed the bug by just noticing that, by just focusing on this function. I have not thought anything else. Just focus on that function, go and see the implementation, fix that, everything else stays the same. Yeah, so too lengthy. I stop here. Okay, now you have done a lot of practice about functions, loops, and a lot of stuff. That was all the basic programming in Python. In the next video, from the next video, we will see the real power, much more real power of Python, where you need not write a lot of loops and a lot of code, and still you will be able to achieve a lot of stuff. And for that, we need to go through the data structures that are available in Python. So from the very next video, we will start seeing strings. That's the data structure. We will see list in detail. We will see set in detail. We will see dictionary in detail. We will see tuples in detail. And after going through all these data structures and getting a good grip for the data structures, then finally we will move to the packages that are available for data science, particularly NumPy, Pandas, Matplotlib. And we will see, maybe I include one or two videos for scikit-learn as well. So hope to see you for the whole new phase in Python, the data structures. So hope to see you in the next video.